So the very last thing we're going to cover for this week is like terms. Okay, so a term, first we have to know what a term is, right? It's a number or variable or numbers and variables multiplied together. So for example, x is a term, 7x, negative 12xy squared. These are all terms. Okay, once you start putting in like plus and minus signs between all of your terms, so like when you start having x plus 7x, this is now no longer a term. It's an expression where we are adding terms together. Okay, so these are all your terms. When you start adding and subtracting, that's when you start getting into expressions. When you start having an equal sign and two sides, that's when it's an equation, right? Which we'll go over next week. Okay, so why do we want to know what a term is? Because we need to differentiate like terms. Okay, so like terms are terms that have the same variable raised to the same power. Okay, so sometimes like these 5 and 7, they both have no variable, therefore these are like terms. Okay, so that's a like term. Let's say we have 2x and 5x. Both of them have the variable x, and they are both to the first power. If you don't see, a power, that just means it's 1, right? Because you have 1x, right? But they have the same variable, same power, so those are like terms. Okay. Again, they both have the same variable to the same power, right? So these are like terms. This is a little bit trickier because now you have multiple variables, but if you look, both of them have x to the first power, both of them have y to the first power, so these are like terms. Okay, so we'll do some unlike terms, right? So let's say x and, right, these both have x, but their powers are not the same. Sorry, it's a 1. Right, not the same power, so these are unlike terms. Okay, they both have the same variables, but the y is raised to the second power in this one. Right, so again, these are unlike terms. So it has to be the same variables and the same powers, the same exponents, right? For them to be like terms. Why does it matter to know if terms are alike or unlike? Because we can add together like terms. So this is just adding more into how we simplify expressions, because again, simplifying is so important. You can add any kind of like term together. So first we need to break down a term. So let's say we have 2x. This number in front is called the coefficient. And of course, this is called the variable, right? So in like terms, you can add the coefficient together to combine them. Right, so just do some examples. So like if we have 3y squared, right, the coefficient is 3. 5xy, the coefficient is 5. Right. Y, the coefficient is, this is that identity property that I was talking about. Because if you remember, y is equal to 1 times y, right? That's the identity property. That means its coefficient, the number in front of it, is 1. So this is a really tricky one. Students always get stumped by this. And I know it seems like the identity property is simple. This is what I was talking about when I say we use it a lot in algebra, right? Even though it seems really simple. So if you see a variable by itself, you have to remember it's super important that its coefficient is 1. Okay, so then we can add together coefficients in like terms. So let's say we have 2x plus 3x. Okay. They both are like terms because they both have x to the same power. That means I can add together the coefficients, right? So 2 plus 3 is 5, and I just keep the x the same. Okay, so it's 5x, 2x plus 3x. They are like terms. I can add together the coefficients, and I get 5x. Another way you can think about this is like common factors. 2x plus 3x, right? Oh, press the button. Their common factor, right, is x. X times 2 would give me 2x. X times 3 would give me 3x, right? And then if I did PEMDAS, I would be getting x times 2 plus 3 is 5. Commutative property I can write in any order. I still get 5x, right? So the distribution way or the really simple like terms way. Okay, so that's why we like to know what our like terms are, because we can simplify expressions. Right, so let's just do a bunch of examples. Right, so 2x plus 7x. First thing you want to do is check, are these like terms? Yes, they are. I can add 2 and 7 together. I get 9x. 3y, 9y, they like terms? Yes, they are. 3 minus 9, pay attention to your sign, is going to be negative 6. Why? This time we have 3, but they're all alike. So 2 plus 4 is 6, plus 3 is 9. We get 9x. Right, and then you're going to start getting to problems where you have multiple variables. Oops, sorry. Plus 4x. So this time this is why we want to know what's like and what's not. These two are alike, right? X and 4x, they both have x to the first power. The y is not alike. So if you remember your commutative, I could rewrite this. You don't have to. Just sometimes I like to make it so that, let's put my like terms, let's group them together in my problem so I can easily see that. This is that identity property I was telling everyone about. Right, what is x plus 4x? Remember, it's got a 1 in front of it. It's 1 times x. So it would be 1 plus 4 gives us 5x plus 2y. Okay, so that's that one. That's the simplest I can get it, because again, I don't know what x and y are, not yet at least. We're going to get a little bit more complicated. Okay, so when you're simplifying, it's still important to use PEMDAS, right? So we're going to do parentheses. We can't combine that, right? So instead of combining, I can distribute, right? So then we get 5x plus 3 times x is 3x And then this is, you have to pay attention. It's positive 3 times negative, so minus 3 times 2. Okay. So then I'm going to do PEMDAS still, right? So that means I should do this multiplication next. 3 times 2 is 6. And now I'm going to add and subtract left to right. These are like terms, so I can add them together. I can combine them. So I get 8x minus 6. You can see why simplifying is so nice, right? Look how simple 8x minus 6 is compared to what it was originally, right? That was really complicated. That's why we simplify. Right, we're getting more and more complicated, but we know all of the steps to this now. We know to do PEMDAS, and we know how to distribute. Remember, you distribute in the parentheses, so I don't distribute past this parentheses here. And I have another distribution. So this problem just has 2 distributions. We still know all the steps. It looks complicated, but it's actually, we have all the tools to do it. 2 times x minus 2 times 5. Then I'm going to carry down my plus sign. 5 times 4 minus 5 times 2x. Okay. And then I'm going to do all of my multiplication left to right. Right, 5 times 2 times x is 10 times x. All right, and then I'm going to combine all my like terms. So some people can do this in their head. So I know I can do negative 10 plus 20, 2x minus 10x. This is that, or you could do the adding the opposite. So you see I have a lot of subtraction in here. And remember, subtraction is not commutative, right? I can't switch 5 minus 2 to 2 minus 5. I'm not going to get the same answer that way, right? But addition is commutative, right? And if you remember, subtraction is the same thing as adding the opposite. So I can change all the subtractions in a problem to addition. And when I do that, now I have a completely all addition problem, and I can write this in any order I want. So it's negative 10 plus 20 plus 2x plus negative 10x. Right, so I just rearranged the order. Again, because I like to group my like terms together. You don't have to do this. If you can do it in your head, that's great too. But I just wanted to show you, this is one of the reasons we learned that adding the opposite, so that you can rearrange your problems and combine all your like terms this way. Right, so negative 10 plus 20 is positive 10. 2x plus negative 10x is negative 8x. So I end up with 10 minus 8x, which again is so much simpler, right, than what we started out with. But maybe you don't have to do this step right here. If you don't want to, you can just do it in your head. You can be like, okay, negative 10 or minus 10 plus 20 gives me 10, 2x, and the negative 10x on this end gives me negative 8x, right? And you just skip the step, do it in your head. Whatever you need to do, if writing it out helps you. If it doesn't, then, however it works for you to get you to that answer at the end. But otherwise, you should have all these tools. You now can do pretty complex problems, simplify them into nice little simple expressions. And yeah, that's what we've been working on throughout the week, from learning about variables to now being able to simplify pretty complex expressions. You have your tools like combining like terms, distribution, and yeah, so hopefully these are all helpful for you. And next